In this example, we will anti-differentiate the function 4x divided by x minus 1 squared times x plus 1. Now, since the integrand is a proper rational function, our first step in terms of evaluating the antiderivative will be to write out the partial fraction decomposition, and then once we solve for the constants, to go ahead and anti-differentiate. So the form of the partial fraction decomposition, so our denominator is made up of a repeated linear term and a linear term. So it's going to have three pieces. A over x minus 1 plus b over x minus 1 squared plus c over x plus 1. Now, in order to solve for the a, b, and c, we take the denominator on the left and we multiply both sides of the equation by it. So 4x is equal to a times, in the first term, a single x minus 1 cancels. In the second term, both of the x minus 1's cancel. And in the third term, the x plus 1 cancels. And when we are in this position, our first step is to always look at for intelligent choices of x that we can plug in. And looking at the terms that we have, we see that if we plug in x equals 1, the a term is going to vanish and the c term is going to vanish, and we'll be able to solve for b. So if we plug in x equals 1, on the left we have 4, and on the right we have b times 2. So b is equal to 2. Now likewise, we note that if we plug in x equals minus 1, the a term vanishes and the b term vanishes so that we can solve for c. So if we let x be equal to minus 1, on the left-hand side we have minus 4, and on the right-hand side we have c times 4, which tells us that c is equal to minus 1. Now, in order to solve for the value of a, we're going to expand on the on the right-hand side so we can set up a system of equations. And if you expand on the left-hand side here, and I'm going to leave out one algebra step, you will have a plus c times x squared plus b minus 2c times x plus the quantity minus a plus b plus c. And on the left-hand side, we have 0x squared plus 4x plus 0. And since we know the values of b and c, we only need to set up one equation to solve for a. We can simply equate together the coefficients of x squared. So a plus c is equal to 0, which tells us a is equal to minus c, and that means that a is equal to 1. So now that we have found the values of the a, b, and c in the partial fraction decomposition, we simply put everything together. So the antiderivative that we are looking for, 4x over x minus 1 squared times x plus 1, is equal to the antiderivative of a over x minus 1 plus b over x minus 1 squared plus c over x plus 1. And now we can anti-differentiate term by term. The antiderivative of 1 over x minus 1 is natural log absolute value of x minus 1. The antiderivative of 2 over x minus 1 squared. This is something you can either write down, or if you need to, you can always use a u substitution. You could, in this second integral, use the substitution u equals x minus 1, and you would find that the antiderivative is minus 2 over x minus 1, something that we could very easily check via differentiation, minus, for the last term, natural log of absolute value x plus 1. And it's an indefinite integral, so we finished with a plus c.